Thank you for tuning in and reading me first. I am the Geezer, and I'm here to talk about climate. The burning of fossil fuels is increasing carbon dioxide levels in the atmosphere, which is warming the Earth's temperature. To date, we're at about 1.1 degrees Celsius above our pre-industrial temperature range. And this is a virtual statistical certainty, so it really doesn't matter if I believe it or you believe it or anybody else in particular believes it. This is what's happening, and we know that with a high degree of certainty. Now, the reason I'm making this series of videos is because I think for any given individual, it's hard to go out there and mine for the information. There's so many places that you have to look, and we're all inundated with information on climate change and what it's causing, so it gets to be daunting. So my goal, what I'm trying to do with these videos, is to create a series of bite-sized bits of information that that anybody can look at, and it's hopefully basic enough that you can see how do we know this is happening, what's happening, and so forth, so you can put the pieces together and start to understand with a fair amount of detail what's going on. Now let me introduce you to the IPCC, which is the International Panel on Climate Change. And this is a group that's been around for quite a while. They're sponsored by the United Nations and the World Meteorological Association. This is the group that was responsible for providing the information and the framework for the Paris Agreement, which many of you have no doubt heard. So the IPCC has put together this report that the screenshot behind me here came out last year. Virtually all the world leaders, I believe, have access to this report. It's certainly been in front of the U.S. Congress and executive branch. Now, whether or not they understand the information or have spent any time looking through it, I don't know, but they have this information. So the graph that's behind me now is like one of the leading parts of this report, the executive summaries of the things you need to know from what's going on with the reporting that they're doing. So first of all, it goes from left to right from 1900 to 2100, so into the past and into the future. It's also temperature calibrated, going from blue to orange, and you can see the calibration bar down there in the bottom. So if you zero in on that 70-year-old person in 2020, that's me. I mean, I wasn't 70 in 2020, but I am now. And if you look at the color of that graphic, that figure is orangish. And what that's reflecting the 1.1 degree Celsius change in temperature that I've talked about. So I've experienced that in my lifetime. But the most important one to look at is the one out there on the right side, which is the 70-year-old near the end of the century, which is my grandchildren and possibly even my children. And if you look carefully at that figure, it has a range. It goes from kind of the orange that my color is up to dark red, even black. And what that means, by looking at those bars labeled from very low to very high. So what those mean is in the very low scenario, that's saying that if we enabled the climate policies that we agreed to in the Paris Protocol, Paris Agreement, then we would see almost a constant temperature from now through the end of the century. And the sobering thing there is that if we're doing everything we can possible, we're not reducing the temperature, we're kind of maintaining where we are today, and that in itself is a little bit frightening. But if you go to the very high bar, what that's saying is we're ignoring the policies, we're not meeting what we said we would do, and that's saying that there's a very, the impact of not doing things has a very high impact on those future generations, and meaning that the temperature change that they're likely to see is going to be even greater. And that's not a good thing, and that's what keeps me awake at night. We're on the cusp of how we respond and act over the next few years will determine the consequences that our children and grandchildren. You might be wondering, and rightly so, who is this geezer talking to me about climate? Well, let me give you two big facts right up front. First of all, I am indeed a geezer. I'm not young and I'm not dead yet, so I certainly qualify there. And the other point that I would make is that I am not a climatologist. So there goes the credibility, right? Well, let me tell you a little bit of my story, and interestingly, it weaves into the discussion that we're having now on climate change, even though I'm not a climate change expert. I did my graduate work at the University of Texas, go Longhorns, and I was doing it on the conversion of solar energy conversion into electricity and energy for other types of reactions. During the time I was there, I had this drawing above my shoulder on my desk. It was actually a clip from a magazine, and I felt like, okay, it's the solar guy. He's plugging into the sun and making it all work. And I lost the original clipping, and a friend of mine just recently did this rendition for me. But anyway, I looked back then at, not comprehensively, but I'd question, do we have enough solar energy impinging on the Earth to be able to use that as a viable form of electricity? And I kind of came to the conclusion the answer was no, partly because the efficiencies we were getting back then were a lot less than what we're able to get today. And now, solar energy is never going to be the only part of our grid, but it's going to continue to be an integral component, and actually one of the lowest cost, if not the lowest cost form of electrical energy that we have. So things have a way of working out. Anyway, I went to start working with big companies ending in M, and I was in New York, and I got a job offer to come back to Austin, which is where my family and I wanted to be. And the job they gave me was working on a project related to the Montreal Protocol. Some of you might remember that was in the late 80s, and the issue was that we were destroying the ozone layer by emitting chlorofluorocarbons of different kinds, air conditioner, refrigerants. We were doing cleaning of electronic materials. So that was our project that got handed to us. So we did that. We converted all of our cleaning capabilities from these CFC cleaners into essentially soapy water. It was kind of a big job because electronics don't like water, but we managed to work that out. Now, interestingly, at least to me, the Montreal Protocol was the same cast of characters, and that were both doing the science and organizing all the countries to band together and say, look, we got a big problem here, we got to solve it. And they put the science out. The countries basically agreed, very similar format to the Paris Agreement, and it worked. We, meaning all of us together, stopped reducing critical amounts of CFCs, and our ozone hole is getting better. And we're able to measure and predict when it'll be completely back to normal, which will probably be in another 10 or 15 years. So these guys do good work, and it's the same approach basically that we're using for the climate models, but we've learned so much more, and the systems are so much more powerful. It's unbelievable how much more powerful they are. Okay, so I had this solar energy vector and this Montreal Protocol vector, ozone vector, and then after I retired from big companies ending in M, I was working as an adjunct professor at the National University of Singapore, and I was teaching graduate engineering students. And of all the things that I've done in all of my career, I think I probably enjoyed this one the most. They're just such bright people to be working with, and energetic and good at what they do. Anyway, I was teaching a module in strategic new product development, because that's what I did for all my big company careers, was introduce new things into the marketplace. So I know things about doing that, and not only from a big company perspective, but from a startup perspective as well. So I think, and then I guess one of the last things I did, I had a consulting job with a medical company in Malaysia, and we were using some cutting edge statistical tools that had just been introduced by the University of Minnesota, and it was a interesting, fun consultation, because I was working with my client on the one hand, but I was plugged into through a friend of mine, into the University of Minnesota, trying to understand exactly how to do this approach. So it's like teaching on one hand and learning on the other, and that's the best way to do things. And we did that program successfully with this company, and I think they learned some things about their very complicated process. So I've done statistical analysis, data modeling. I've worked on programs related to solar and freon reduction, ozone reduction, ozone depletion reduction, and anyway, those are the things, with that knowledge, I hope that I can dig into some information and convey it to you in a simple, concise format, so it makes sense. And like the Montreal Protocol work, so what if the ozone layer healing was slower than we thought? Would it be all bad that we weren't using a fairly nasty chemical to clean circuit boards all around the world, and we're using soapy water instead? I mean, that's a plus. I mean, these things, these solutions to these problems are going to be win-wins. We're going to create some new business, and there's so much room for entrepreneurs in this space. Anyway, it's those combination of things that give me the energy and the desire to want to express this information to you. Thanks for listening in. One final comment from my students that listen to my lecture videos. These are guaranteed to put you asleep. So if by any chance you've actually gotten this far, I'm amazed, because usually more than a little less than halfway through, most people have fallen asleep or listened to it on 1.5 speed. Whatever works. Cheers.